Let's try out these few examples. So, this question says express in terms of root of 2. So, we've been given an idea, so this one's quite easy. Given an idea that what we want is to have root of 2 and answer with root of 2. So, we can simply say 2 into 8, which would be 2, should be 4, sorry, which is 4. So, we can have 2 times 4, which is 8. So, we're doing this because, remember we said root of AB is equal to root of A times root of B. So this is what we're trying to achieve. So we can also do the same for 32. So 2 into 32 is 16 times 2. And we know 16 has a square root, so that'd be okay. And we have 3. 2 into 50, that would be 25, so 2 times 25. So we can now say, okay, root of 4. So since it's going to be 2, root of 4, root of 2, minus root of 16 times root of 2 plus 3 root of 25 and root of 2. So root of 4 is simply 2, and 2 times 2 is 4. So it's going to have 4 root of 2 minus, we know root of 16 is 4. So 4 root of 2. And we know root of 25 is 5. 5 times 3 is 15. So plus 15 root of 2. And well, root of 4, 4 root of 2 minus 4 root of 2, this is 0, is cancelled out. So the final answer is 15 root of 2. This is our answer. So we do the same for the other question. So it's quite easier when you're given something like this. Well, even if you're not, you can find the main something. You can find the common factor. Do this now. So for this one, so 2 into 18. 2 into 18 is simply write that down. 9 4 times root of 2 plus, so it's going to be 36 root of 2. So 3, and we know root of 2 is 3. So we know 3 root of 3 is 3. So 3 times 3, that's going to be 9. 9 root of 2 plus, we know root of 36 is 6. So 6 times 6 is 36. And 6 times 2, that's going to be 12. So 12 root of 2. And 9 plus 12 is 21. So we have 21 root of 2, which is our answer. So let's try out this one. So for this one, we can see that the denominator is irrational or not rational. So if you remember what we said we have to turn this into a rational number by multiplying by the conjugate, which is, so this is a little bit different from doing, let's say for example, if there was 5 minus I. So if it was 5 minus I, the conjugate would be 5 plus I. Or if it was I minus 5, the conjugate would be negative I minus 5. So, but for this case, it doesn't matter where the root is, as long as if it says 2 root of 5 plus 1, then the conjugate root, where the positive, just change the sign. And if even if they're swapped, that's what. And even if they're swapped, all you have to do is just change the sign for this one. So, okay, let me just get rid of this. Okay. Okay, so that would be 2, 5 minus 1. Okay, so 3 root of 5 times 2 root of 5, that's going to be 6. 6, and root of 5, the roots cancel out, so we got 5. So we got 5 because the roots cancel out. So 3 root of 5 times negative 1 is going to be negative 3 root of 5. Negative 4 times 2 root of 5, that's going to be 8. Negative 8 root of 5. Negative 4 root of it's negative 4, sorry, times negative 1 is going to be positive 4. And everything over 2 root of 5 times 2 root of 5 is going to be 4. And 4 times 5, because roots cancel. 2 root of 5 times negative 1 is going to be negative 2 root of 5. Be plus, and 1 times 2 root of 5 is going to be 2 root of 5. 2 root of 5. 1 times negative 1, negative 1. You can see this cancels out. So we have 6 times 5, 30. 30. And we have, so we can see that the 5 here is the same. So we can just simply, well, say negative 3 minus 8, that's going to be 11, negative 11 root of 5, and this is plus 4. Everything over, this is 20 minus 1. Just do that. So 30 plus 4 is going to give us 34. 34 minus 11 root of 5 over 21. And we can simply say 34 over 21 minus 11 root of 5 over 21. Sorry, I beg your pardon, this is 19. This is 19, not 21. This is 19, let's just correct that. This is 19. 19, and there's nothing common that can go into 4 and 19, so this we can just simplify and say, so this would be our final answer, over 19 minus 11 over 19 root of 5, and this is the answer. Okay, now let's change this. Let's try another question. Let's say there was 3 here. Put the 3 here. Okay, and let's try this question. Now for this one, this is a combination of, well, two concepts, conjugate and surds. So with here we've been given 3 root of 3, so which would make our life easy. So just simply try to find what would go into this. So 3 into 25 into 25 into 25, sorry, this is supposed to be 27. Okay, supposed to be 27, and 3 into 27, yes, that is 9. So we're going to have 9 times 3, everything over 2 plus, and 3 into 75, that is 25. We have 25 times 3. So here I have 9 times 2 will give us 27, 25 times 3 will give us 75. So now we have 1 minus, well, root of 9, sorry, is 3. So we have 3, and 3 does not have a root, a perfect square, sorry, perfect square, so it stays the same. And we have 2 plus 25, 25, 5 times 5 is 25, so I have 5, and 3 does not have perfect square, so we have this. And from here now we can rationalize the denominator, where we can say, okay, by the conjugate, denominator by the conjugate, which is 2 minus 5 root of 3. And we can further say, okay, 1 times 2, that's going to be 2. Let me do this properly. Okay, which is 2. 1 times, well, 5 root of 3, that's going to be 5 root of 3, negative 5 root of 3, 5 root of 3, just plus this, and 3 times negative 3 root of 3 times 2, that's going to be negative 6 root of 3, 6 root of 3, negative 3 root of 3 times negative 5, that's going to be positive 15 times 3, since the roots cancel, and over 2 times 2, that's 4. We know that this 75 will cancel out with, sorry, this, we're following this, sorry, we're going to find that this will cancel out. We're going to have 5, we're going to just have 5 times negative 5 root of 3, that's going to be, sorry, 5 times 5, that's 25, so that's negative 25, and the roots cancel, we're going to have 3 there. Then we go on and say, okay, 3 times 15, that's 45, and 45, 2 plus 45, that's 47. We want to have 47, and now we have negative 5 root of 3 minus 6 root of 3, which is going to be 11, so minus 11 root of 3 over 25 times 3, which is 75 plus, or minus 4, sorry, 25 minus 4, which is going to be negative 71, and from here we say 47, negative 47 over 71, actually negative 71, so here there's negative, so this becomes plus because of the negative 71 over 11 71 and root of 3, and we know that this does not have we cannot simplify this here, so we can leave the answer like this. Let's try our last example. So let's try these others. So this one just says simplify. So in simplifying, we look at the roots and find common factor, one thing that can go into both of them. And for here, I can see, let's see, 4, 3, 3 can go into 12. That would be 4. So we can say 4 times 3 minus 5, and you can see, okay, 3 here, 9, so 9 times 3. So from here we can say, okay, root of 2, root of 4, that's going to be 2. So 2 times root of 3 minus root of 9 is 3. 3 times 15, 6 times 5, that's going to be 15. 15 root of 3. And then now we can say 15 minus 2, which is 13. 13 root of 3. 13 root of 3. And that's the answer for this one. Let's try this one. This one, again, we've tried to find a number that can go into all these 180, 245, and 80. And that number is, well, 5. 5 can go into 80 16 times. So we say 16 times 5 minus 5 into 245, it's going to be 49. You just verify 9 times 5, 245, okay, times 5 plus 2, 5 into 180 is going to be 36. 36 times 5. 36 times 5. So 3 root of 6. Root of 6 is 4. So 4 times 3 is going to be 12. So just put 12 here. 12 here. Over root of, and root times root of 5. Minus 49 root of 49 is 7. So it's going to be 7 root of 5 plus root of 36 is 6. So 6 times 2, that's 12. 12 root of 5. And you can simply add 12. Sorry, you can subtract 12 from 7. It's going to be, that's going to be 5. 5. 5 root of 5 plus 12 plus 12 root of 5, which is equal to, plus 12, which is equal to 17. 17 root of 5, which is our answer. And finally we can say for this one, just do that. Do that. Find a number that can go into both 343 and 5 and 252. That would be 7. 7, so that would be 49 times 7 times root of 7, actually. Yes, 7. And 36. 36 times 7. All this under root. Okay, so root of 49 is 7. 7 times 2, that will be 14. So here we have 14 root of 7 over 6 root of 7. So these two cancel out. Let's do this. The roots cancel out, and we find that we know 2 can go here 3 times, and 2 can go there 7. So our final answer will be 7 over 3. And there you have it.